Okay, so in the last two videos I have drifted to some extent away from whatever is given in our textbook. So from this video onwards I will try to veer our course back to the textbook. Our textbook, as I have already said, has a very good habit of describing how you analyze data. It's not merely about analyzing using linear models, but how you prepare the data, how you look at data, and all those things. And the very first chapter, the introductory chapter, gives you some hands-on training on that. So we will actually go through part of that to give you a flavor. I am not going to reproduce anything and everything that is already there in the book, but I will just give you some flavor. The first thing is that many students make this mistake when they work in R, is that they start R and then they will continue to type various commands right in front of the command prompt and hit enter and keep on working. After some time they will get confused and possibly have to leave off, and then they lose track of whatever they were doing when they left off, what they have learned and what they have not learned. And in case you want to communicate later with me saying that I tried this and I do not understand why this happened, you do not have all the commands in one place. They are typed all over the place, there are mistakes, typos, error messages, everything becomes just a big lump. So what I would suggest is that you start some text editor, something like Notepad or whatever. I am here using Ubuntu, so I have used some editor which is called Emacs. You do not have to use that. You open some text editor and type all your commands there. And also you keep the window for R open side by side. Now you can use this text editor, or if you are using R in Windows, it already has a built-in text editor. You can open that also. Or you can use R Studio. But whatever you do, you keep all the commands in one file, one script file, and then copy and paste the commands one at a time, or maybe a few lines together onto the R command prompt and then execute it. Now there are smarter ways of doing this. If you are using R Studio or if you are using some other sophisticated thing, it is possible to send the commands in your text window directly to R. You can figure those things out yourself once you are more or less conversant with the working procedure of R. So here I shall be using the crudest thing, namely I will write everything in a text editor and then copy and paste the appropriate lines into the R command prompt. If I find that there is any mistake, I will change it in my text file and then again run it, so that my text file always has the most up-to-date commands. Okay, so that's advice number one. Now let's start with our textbook. Our textbook has a nice package with it, and that package is called Faraway. So what I will do is I will first need to install the package called Faraway. So you go to the R command prompt and you type install.packages, then within quotes, double quotes or single quotes. R accepts both double quote or single quote, Faraway, and then you will hit enter. In my case, however, I do not need to hit enter because I have already installed the package in my computer. Now when you try to install this, three possible things might happen. First thing, which will happen in most of the cases, it will just install without any hitch. But remember, when you execute this command, you must be connected to the internet. Otherwise, it will not work. The second thing is, it will give you a list of lots of websites or their mirrors, the R mirrors, where these packages are stored all over the globe. And it will ask you to pick one of those things. My suggestion is always pick the very first one in the list, which is called something like cloud, etc., etc. So pick that. And then hit OK, and it will be installing just very simply. The third scenario is that you do this and you get an error message which says that some library folder is not writable. You do not have access to some library folder. That will be a bit irritating. That happens when you are working in a Windows machine and you are not an administrator, because whenever you are downloading things in R, they will be stored in a certain place, some place in the hard drive. And certain part of the hard drive is not meant to be written by ordinary users, that is, other than administrators. So if you do not have administrator privilege, in that case, the computer or R might complain saying that I do not have access to that place. If that is the case, then what you have to do is, you again write install.packages, name of the thing, then you write lib, lib, equal to, then within double quotes, you write down the path of some folder that is indeed accessible to you. It could be your user folder, something like, if you are in C, it could be C:/users, then your name. I do not know how your computer is configured, but it could be something like this: C:/, not /. Even if you are in Windows, it will take /, or you might try double /. / I do not know how it is in your machine, but it could be users and then whatever your name is. Suppose your name is ABC, then ABC. In that case, it will install everything in that particular folder. So it all depends on how your thing is. But if you still have any problem, I would suggest that you let me know in our class session or by email or whatever. Okay, so in my case, I have it already installed, so I do not need to run it. This is to be done only once per computer. So if you are working on 2 different computers, you have to do it once for each computer. But if you shut it down and then start it again, fine, your package will stay there. But every time you start our session and you want to use that package, you have to use this command library far away. And here R silently returned the prompt, meaning it could find that library and it could install it without any problem. It does not give any message that it has really loaded. If it just returns the prompt silently, that means it's fine. No news is good news. Okay, so there are various data sets, etc. inside that package. You can just look up the book or the web page or whatever to find out what are the things in it. You can even try this. I do not know whether it is going to work, although it is not working that way. So if you just ask for help on far away, it does not have any built-in help for that. Just notice how I asked for help. I typed a question mark followed by the name on which I was looking for help. Anyway, I am following the first chapter in the book, and the first chapter in the book says that there is a data set called pima. So I will type pima and hit enter, and indeed my screen is flooded with lots of numbers. So there is indeed something called pima in that package. Okay, so when you are overwhelmed with so many things, what you can try to do is to look at the first few columns, or the first few rows rather. But before that, I like to look at the size. And size is given by dimension, DIM of pima, that is 768 by 9, which means 768 rows and 9 columns. You can take a look at whatever you want. So I will like to take a look at the names of the variable, names pima. Well, here I am typing things directly, but you should do possibly what I say. Type it here and then copy paste. So type it here and then copy paste. That's a better way, because later you might forget what are the commands that you have given. Now you know that these are the things that you have given. Here's another command which is called head. It shows you the first few rows of the data set. Now my screen is only half of the thing, so I can hardly see anything. So I can see that I have got some variables: pregnant, glucose, diastolic, triceps, insulin, BMI, diabetes, age, and test. Now naturally you want the story behind this. You can get that by looking up the help I will type question mark PIMA, and indeed I get some help. It says diabetes survey on Pima Indians. There is some description, and it has a description of all the variables that is each column. Pregnant is number of times pregnant, glucose is this, and you want to go down the screen, you just hit your space bar and you go on like this. Finally it gives you the source, so that if you want to take a more detailed look at it, you might try to look up this website. Now how do you get out of this page? You just hit Q. You just hit Q and you get back to your command prompt. If you are using RStudio, then this help will open in a different window, a different panel, so it will not obstruct your command prompt. Okay, so that is basically how you first look at a data set. You type head, you type dimension, you type names, you look up the help to see the description, and that's how you first get your fill. Then, since there are so many numbers, you surely cannot look at all the numbers simultaneously. There is a very useful command which is called summary. Summary of Pima, and it will compute summary of all the different things. Again, my screen is half, so you cannot see it clearly, but now I will show you. For pregnant, it gives you all the things: minimum, the first quartile, median, mean, the third quartile, the maximum. So you have an idea about the range and how the things are spread and things like that. Now, as the book points out, you should look carefully at all these things, and you will possibly see certain things which are strange. For example, here is diastolic, which is diastolic blood pressure, but surprisingly its minimum is 0. You never hear of a person whose blood pressure happens to be 0. So you suspect that there is something bad going on there. And ideally, as the book suggests, if you have access to the main source of the data, you should query that main source, figuring out what this is. But in this case, the natural case is that for some of those cases, we did not have, or the persons who created the data set did not have the values for the diastolic blood pressure, and they indicated the missing value by using the number 0, which is a pretty bad choice, because 0 is being just a number. It looks like any other number. So you should use something which sort of stands out. So the way to fix that will be this. This is the command I have from the book, and this is a somewhat complicated command, so I would like to break it up. We have all these variables, like I have a variable called pregnant. I have a variable called diastolic. Now if you want to look at the value of the diastolic, you might try typing diastolic, and it will say this is not found, because the Pima thing is like a box. The data set is like a box, and this diastolic variable is inside the box. You want to talk about the diastolic variable that is inside that Pima box. And for that, what you need to do is to do the following: Pima $diastolic. And now you can see all the diastolic values. There is yet another way of doing it, which is like opening the box and turning it upside down so that all the variables come out, which is not the preferred way of doing it, because it clutters your workspace with lots of variables, even variables that you possibly do not care about. But to save time, we can sometimes do that. So I will just show it here, not do it. Attach Pima. So if you do that, attach Pima, in that case, all those variables will now become visible. Attach Pima. Well, I should have copied and pasted since I have already typed it here. And it says something that the following object is masked from package far away, which means that there was something called diabetes already. Now, on top of this, we have created a new variable called this diabetes. So now if I try diabetes, you will see the variable. If I try pregnant, you will see that variable. So all those things are now sort of top level variables. They are no more inside that box. I personally do not like to attach everything because it creates so many variables and very soon you get confused. You do not have any control on the names that you are using. So I will just get rid of that. I just showed that. You use detach pima, detach pima, and now all those things will have vanished. If I now type pregnant, and it will again say I do not see anything called pregnant. So you put all the variables back in the box and locked it. But you can still see pima $pregnant, and that will work. Now typing all these things sometimes is a lot of work. You can type $preg, that will work. $PR, that will also work. So as long as it does not clash with any other name, it will happily accept them. Okay, so now let's get back to our diastolic thing. We notice that some of the things were zeros. Now we do not like that. We want to indicate using some smarter technique that these are missing values. The way to do it is to first check where the values are. And for this, the command is pima $diastolic is 0. So suppose I store it in some variable which I call bad. Bad equal to pima $diastolic 0. What it does is that I will just make it full string. Bad equal to, it's a long list of true and false. So what it's doing is the following. When I put this double equality, this is checking a condition, just like in C programming. So it is checking a condition whether it is equal to 0 or not. If so, it is putting a tick mark against that case, and if not, it is putting a cross mark against that case. And these are the things, the trues are the tick marks and the falses are the cross marks. Here I can see, for example, a true, and this occurs in case number, this is 589, so 590. The 590th case. So if you look up the entire data set, look at the 590th row in your data set, there the value of diastolic is 0. And similarly in this is 601, so this should be 602. So there you have the value 0. So you get all the positions of the indices as true and false. Now, one nice feature about R is that if you now take pima $diastolic, and I'll be lazy, I will just write this, and then I type bad. So I give that as my array index. In that case, it will show me only those particular cases. Wherever I have true, it will show me only that subset. Sorry, this does not work, so I will just have to write the entire thing in this case. So there is something called diam, I do not know. So I did that, and indeed I get the 0, 0, 0 because my band really picks up all those cases where I have a 0 value. Now it is possible to change all those values to whatever value I want, and the standard way R represents missing values is by NA. So I will write this equal to, I will type NA. I just type capital N, capital A, no double quote or anything. And now I will indeed have, if I look at all the values, let's just take a look at them, you will see that there are lots of values with some missing values here and there. That's a better way of encoding missing values. That is important because if you do not recognize that 0 has been used as missing value, you use it for something like regression or say finding out averages. In that case, it will just average it, thinking that some persons had really 0 diastolic pressure. So that will give you just garbage result. So it is always important whenever you get any data set to do some sanity check, to understand what things are, instead of immediately diving into doing mathematics and things like that. Okay, so now I will have to take a look at some plots. So I can do plot. I will use this plot, diabetes versus diastolic. So look at the thing, how I have written the plot command. Plot, then I write diabetes, the thing that I am going to show in y-axis, followed by tilde. We have already seen it in our last video. So this tilde thing is with your formula. Then the x variable, diastolic, comma, the name of the data set. You could as well have typed it as plot, then you could have written pima dollar diabetes, pima dollar diabetes, and here pima dollar diastolic. Then of course you do not have to keep this. So that is also another way of doing it, but the way we wrote it is the smarter of the two. So we prefer to use this. And here is the plot. You can look up the help of plot to figure out how you can customize it. You can change colors, you can change the things that are used, all those plotting characters and everything. I do not care about those things right now, so I will just cross it off. Then I also want to see what is this diabetes against something called test. And this is surprising, because here I see only two columns of things, which shows that test takes only two values, 0 and 1. Obviously it is some kind of a Boolean thing. Either test is done or not done or something like that. You can look up the help. You see that it is actually a binary variable. So trying to say that it is taking values continuously, 0.2, 0.4, etc., that doesn't make any sense. But since this is encoded as numbers, so R thinks it's a continuous variable, whereas it is a categorical variable, which is also called a factor in linear model parlance. So what we have to do is that we have to tell R that we are working with a factor. The way to do it is this. We type pima dollar test, that is test inside the pima data set, is actually a factor. So it converts this into a factor. For that it will go through all the values, figure out what are the distinct values. So those many levels are there, and it will put all those things. So now test has become a factor. And you can see that very easily if you just type your summary command once again. I will just show the summary of test as before. So not summary test, I wanted to say summary pima. Look at this and you will see for test, the summary is not anymore minimum and quantile and mean, because 0 and 1 are used nominally. They are names of two levels. So it merely says 0 occurs 500 times and 1 occurs 268 times. It does not give you anything like mean, median, maximum, minimum, etc. So now it is doing things more intelligently. Now let us see what happens if I try to plot. So let's try to plot. So basically the same command as we used when we wanted to plot against diastolic, but test is a factor. Now you will see that the plot has changed drastically. Now the plot gives you what is called a box and whisker plot, a very useful but somewhat underrated statistical tool, statistical graphical tool. What it says is that whenever test is 0, it has shown all the diabetes values for that, and these lines will give you an idea about the medians and things like that. This thick line is the median. These are the lower first quartile. This is the third quartile. This is the first quartile. This is the third quartile. These whiskers are computed based on this rule. They take this distance and go a certain factor of that distance up. This factor may be computed. Looking at it, it seems it is something like 2 times that or something like that in this direction, and these are all the values which they believe in within a natural range of the data. Any value which is beyond that are suspected outliers. All those points are shown here as dots. Similarly here, this immediately tells you that the scatter in the data is more for the case where test equal to 1 and it is less the case when test equal to 0. It also points out certain suspect cases, like these 4 points here are suspect cases in case of diabetes, and you can try to figure out using R how to find out these points. So suppose you want to know whether this is the 37th row or which cases are these things. There is a smart way in R to do that. I will leave it as an exercise for you to figure out how to do that. Okay, so that's basically all that I wanted to talk about in this video. So you should follow carefully the commands that are given in the book. Do not try to copy and paste, even if you are reading from a soft copy of the book. Type them out. My suggestion, always type them out in some text file, then copy and paste them to the R command prompt. And that way you will really learn whatever new things there are, and you can also add your own comments, like you can add a little comment saying that this is new or this does not work or things like that. And if you have any question, you can send me that particular file. Okay? So that's basically all that I wanted to say. And just one other little suggestion: when you want to send anything to me by email, better not use the extension .r after the file. You can use something like .txt, because sometimes, especially when I want to open the file in Android, this .r extension might cause some problem, but .txt Android is comfortable with. So basically, that's all that I wanted to talk about in this video.